Okay, new unit. We are on unit 3, and today we're going to be talking about 3.1, but this unit we are dealing with exponents. You've probably dealt with some exponents so in the past, so this should be kind of a review. If not, we're learning new things. Okay, so exponents. Let's say in this chapter, what's really important is to kind of remember your exponential forms. So your perfect squares or your perfect cubes, those are things where now it comes in handy to have those in the back of your mind. So let's pull out an example here. Let's say I have 2 to the x minus 9 equals 4. Well, here, if this is x minus 9 equals 4, how do we solve this? Well, I know here 2 is a perfect square. So of 2. So I can say 2 to the x minus 9 equals 2 squared. Well then, since 2 and 2 are equal, I can just then say, well, how do I get x minus 9 equal 2? Well, that makes it that x has to equal 11. Add 9 to both sides, you should get 11. What if it didn't say x minus 9, right? Let's just say x minus 9 equals, instead of 4, let's say 8. Same rules apply. This time, I know that my 8 is 2 cubed. So then I solve the same way. X minus 9 must equal 3. Well then, x must equal 12. The same rules apply with this. Let's say with exponential, with functions with e. So let's say we have x e to the x squared plus 10 equals e to the 7x. Same rules, they both have e's. We just need to see how do we get x squared plus 10 equals 7x. We just need to solve for x, where one has to equal the other. Well, this looks like a quadratic, so I am just gonna solve it as though I would solve a regular quadratic. I am going to move everything to one side, set it equal to 0, and find my roots. Let's see here, I think this is factorable. This is x, 5 and 2, minus 5, minus 2. Well, then my roots are 5 and 2. So x in this case can equal 5 or 2. Right, 5 or 2. Continuing on with the ideas of exponential function, now we want to get into, basically what I like to call the banking system or the loan banking, the money system. And the two formulas we want to have here in our minds is A equals P times 1 plus R over N times T times N. And these are for A, just a little reminder of what A is. A is going to be the amount that you have. So A is the amount. P is going to be your principal. R is your rate. N is going to be the number, but basically the number of times a year, or how many years. Usually it's in the number of times per year that your bank is going to be dinged. So number of times a year, and then T is going to be the number of years, so the actual years that you're going to be investing here. So this first formula, A equals P times all of that. This is for example, if you had a savings account, and this generous savings account, okay? So because most savings account, they pay you once a year. But let's say this very generous savings account pays you 4 times a year, and you put in so the principal is how much you put in. So let's say you put in $15,000. Oh, okay. We're broke college students here. We're broke here. Let's say we're young. We're starting out. We put in $100. We put in our $100 for our principal, and the rate. Usually, you don't get a very good rate for bank accounts, but let's say this is a very generous one, and they say their rate is actually 3%, or 0.03, which is what percentage is in decimals. And the number of times a year that they give you interest for putting money in their bank account, let's say 4 times a year, they give you money. And let's say you just put this $100 in there, right? Just one time, and you didn't put anything else. And you want to see how much money you're going to get after 10 years. So now what I like to do is call plug and chug. So once again, our formula is A equals P times 1 plus R over N times NT. Okay, plug in our numbers. 100 plus 1 plus 0.03 times N 4 times NT. NT is 4 times 10, and we'll plug that into our calculator. And from our calculator, we get $134.83. So that is the amount you will get from the interest after 10 years, only $134.84. And this is a generous bank, okay? So gives you an idea of how wonderful savings accounts are going to do for you. However, let's say we are not putting a savings. Let's say we get a loan, and the loan, most loans, a lot of times, really harsh ones, big ones, they make you pay a continuous interest, right? So the interest is compounded always, every single waking second. And I like to call all these interest equations PERT, because it's principal times R and T, but PERT. And in this case, it is definitely a PERT. Our continuous interest is A equals P E R T. E stands for the exponential equations. So if we were given a bank loan with the exact same amount, right? We got a loan for $100, and we had to pay them back the rate of the 3%, and it's continuous. And they will say, we're going to take 10 years. And this is a ridiculous amount of years to take to pay back a loan. But you know what? $100, who knows? Maybe people don't think that it's going to cost that much. So then we just put it into our calculator, and we get 134.98. So there, you'd actually have to pay a little bit more than what we would kind of get paid once in a while.